We'll recap what we discussed in the last session. In between others will join. We discussed about the regression technique, and by making use of that technique, how to convert the demand schedule to demand equation. There also we highlighted what is the importance of an equation, demand equation, because we know the demand schedule. What extra advantage we will get by knowing the demand equation? That also we have discussed. Means it helping us to forecast the demand. So as you get the demand equation for a particular value of T, you can estimate, forecast what will the quantity demanded in the market. So that will help us as a producer, as a seller, as a supplier, whether I will be going for price cut, price hike or not. So two variables were there, price and quantity demanded, like Y and X. Then we went for applying technique and we did that one. Then today we'll discuss about sales forecasting, which is exactly same as demand forecasting. Only difference is in case of demand forecasting, we were having two variables, price and quantity demanded. Here we'll be having two variables. One is time, time means year, and second is the sales volume. Means the data will be given to us in the form of sales volume of a particular company, a particular product over years, maybe 10 years, 20 years. Data will be given, and we will be finding or forecasting the sales for the forthcoming year, any year in the future. So two variables are also here. One is the time, that is the year, and second is sales. There are two variables were there. One was the price of the commodity and its quantity. So the same thing we'll be doing, applying the regression technique, uh, solving the two normal equations, getting the values of A and B, then fitting the sales equation over here. Okay, so we'll go to the white screen now. Suppose year is given like this, 1990, 1, and sales is given. I'm taking small values so that we can do it easily. 2, 3, means data given to us is about sales volume of a particular product in a company for 5 years. So it is a time series data where two variables are there. Year is one variable, sales is another variable. You please tell me between these two variables, which is dependent variable, which is independent variable. Whether sales depend upon time, or time depends upon sale.
Sales on time.
Sales on time, sales depend on time. Very good. So, like in our y as a function of x, we were writing y is dependent variable, x is independent variable. In demand equation, we did demand is a function of the price. It is dependent variable. It is independent variable. Similarly, now it is sales. So, sales is a function of time. Sales is your dependent variable, and y is your independent variable. That means if you put in the yx form, sales will be y, sales will be y because this one is sales, and year will be x. Okay. While taking year as x, we will not take the as it is value of the year. Rather, we will take the reduced value of the year. Then we will create another column called x. We will take 1990 as 1. Then 91 will be 2. 92 will be 3, 4, and 5. Okay, means first year took 1, then subsequent years we kept on adding or subtracting depending upon the value. Suppose year is given like this. Let's say 90, 1992, 1993. So what will be x? 91 is 1. What will be 92? Not following. Suppose year is given like this: 1990, 1992, 1994, 95, 6. If you are going to take year as x, 90 will take 1. 92 will be what?
2.
2. No, we will not take it serially. We will keep on adding or subtracting depending on the difference. Because 92 is 2 years more than 90, it will be 3. It will be 5. It will be 6. It will be 7. In the previous example, because years were in consecutive term, it was automatically 1, 2, 3, 1, 2, 3, 4, 5. But here there is a jumps: 92, 92, 92 to 94. So we will not take 1, 2, 3 like this. Rather, we'll start with 1. Then we'll see how far the second year is. 92 is from the first year. 2 years gap is there. So 2 will be adding with 1. We'll get 3. Then 92 to 94, again 2 years gap. 3 plus 2 is 5. Is it okay?
No, sir. Can you explain this once, please?
Okay. You see, we took the first year as 1, 1990 as 1, 91 2, 92 3. Then there may be some confusion that probably we will be taking 1, 2, 3 like this serially. No, it is coming serially automatically because all the years are consecutive: 90, 91, 92 consecutive. Therefore, x is 1, 2, 3, 4, 5. We have not done it serially. We have rather added or subtracted depending upon the difference between the 2 years. 90 to 91, if you compare these 2 years, gap is 1 year. So we added 1 with 1 to get 2. Similarly, 91 to 92, gap is 2. So added 1 with 1, 2 to get 3. Similarly, here 90 is taken as 1. So 92 will be how much? Because gap is here 2 years. So we will write here 1 plus 2 is equal to coming 3. Similarly, 92 to 94, gap is 2. So we will add here 3 plus 2 is equal to 5. 94 to 93, 1 is gap. So is equal to 5 plus 1. 7, because 1 is gap. So 6 plus 1. Is it clear? We are not putting the values as per serial number. Rather, we keep on adding depending upon the difference between 2 adjacent years. Okay, so that way we did. Then we know that our regression equation is y is equal to a plus bx. We have done it previously in a demand forecast. Then normal equations are sigma y is equal to na plus b sigma x. Sigma xy is equal to a sigma x plus b sigma square. Okay, so accordingly we will add this one. We get sigma x. It is coming 3, 3, 6, 10, 15. Sigma y 2 plus 4, 6, 7, 3, 10, 12. One more column xy 2, 6, 3, 16, 10. 16 plus 10, 26, 29, 35, 37. Then x square 1, 4, 9, 16, 25. Sigma x square is equal to 25, 25, 50, 55. Okay, then n is equal to how many pairs are there? One pair, second pair, third pair, fourth pair, fifth pair. Then all of you please solve this. We'll put the values over here. Like that sigma y means that is 12. 12 is equal to 5a plus b sigma x. Sigma x is equal to 15. Like that xy 37 is equal to 15a plus b sigma x square, that is 55. Solve these two normal equations and tell me the values of a and b. Could you follow this? Because we have already done this one, exactly same pattern, same process we are following. Simply there is difference in the variable. Their price was there, and here years is there. So we are converting year to x and sales to y. Then x, while taking the x value, we are not taking the as it is value, rather we are taking the reduced value. Okay. So are you solving this one? Yeah. The first equation is 12 is equal to 5a plus 15b. Second equation 37 is equal to 15a plus 55b. So solve these two simultaneous equation either by substitution method or by elimination method and tell me the values. Values of a and b.
Sir, A is 2.1 and B is 0.1.
A is equal to 2.1, B is equal to 0.1.
Yes, sir.
Okay. Anybody please confirm this one? Whether this is the
Yes,
answer?
sir.
A is equal to, yeah. Okay. Then our regression equation will be y is equal to 2.1 is a plus 0.1 x. This is the regression equation, or we can call it as also sales equation. No, 2.1 sales equation. So sales data is there. We got the sales equation. But question will be forecast the sale for the year 1996. Suppose question is there. Data is given regarding the sales volume of a particular company, a product for 5 years. Find the sales volume for 1996. 1996. And after fitting this sales equation, we will write for 1996. What is the x value? You see, 94 was 5. 96 is 2 year. No, 2 year more than 94. So it will be 7. X equals 7. Therefore, so here now it is for y is equal to 2.1 plus 0.1 into 7. So this is the forecasted sales for 1996. Is it clear?
Yes, sir.
Yeah, this is not a new concept. The same concept what we did in the demand function, it has been extended to sales. Okay. One more thing I will add over here. While converting the year to x, the way we did here is called direct method. Means 90 is 1, first year is 1, then subsequent years we kept on adding and got the x value. Direct method. But there is also shortcut method. Suppose year is given like this: 1990, 91, 92, 93, 94. So we'll first convert it to x. As per shortcut method, we have to assign year such values that sigma x will be 0. Therefore, what we can do, to take the middle year 0, then it will be -1, it will be -2, it will be 1, it will be 2, so that sigma x becoming 0. The middle year we are taking as 0. Accordingly, 92 and 91, if you compare, 91 is 1 year less than 92, so 0 minus 1, 0 minus 1. 92 is less than, sorry, 90 is less than 1 year less than 91, so it is -1 is equal to -2, and so on. Could you follow this? No.
Yes, sir.
Okay. Respond, because sometimes I'm thinking that probably I'm not in a network. I got disconnected. It seems no. So while I'm asking, please respond. Somebody.
Sir, what
Okay.
if the year is given in even numbers?
That I'm coming. That I'm coming. Because he's a good question. That if the number of years is even, in that case, what to do? Okay. First, we will explain this one. It is sigma x coming 0. Then why it is called a shortcut method? If you do like this, it is shortcut method because by doing so, our sigma x is becoming 0. Means, you see, in the normal equation, this will be not there, this will be not there because sigma x is equal to 0. So directly you will get sigma y is equal to ma. Means there is no need of solving the simultaneous equation. Directly you will get the values. You can save some time by reducing the calculation. Because in the two normal equations, two terms will be missing. B sigma x will be 0, A sigma x will be 0 because we are putting sigma x at 0. Therefore, we will get the value to 0. Okay. Still, I will be advising you to go by the direct method because there may be some problem in the shortcut method that I will be highlighting now. Okay. Coming to what he rightly pointed, now it is odd number of years, so we could make it easily. Suppose it is now 95. And 6 numbers of years are there. Then what to do? Because middle year is not single one, it is 2. These 2 years are in middle. Okay. So what we'll do here? Here we will take 92 years 6 months, means 92.5 as 0. That will not write in the note, but we will presume of our own that 92.5 is 0. Then what will be 92? If 92.5
0.5.
minus 0.5.
Yes, -1.
Minus 0.5. So it will be minus 0.5. It will be plus 0.5. It will be minus 1.5. It will be plus 1.5. It will be minus 2.5. It will be plus 2.5. So accordingly, sigma x will be equal to 0. So be it even number of years or odd number of years, you can take x values to make sigma x 0, and hence you can reduce the calculation. Then question comes, why am I denouncing to take that? Anyway,
That equal interval of years may not be there.
equal?
So the gap between years may not be equal.
Yeah, very good, very good. So this is the point. In both the examples, what we have got, you please mute. In both the examples, what we have got, all the years are giving any consecutive terms. There is no gap between the years. What he rightly said. But it's not necessary that every time you'll get this type of question. Suppose you got like this: 1990, 1992, 1994, 1995, 1996. Like this, you have got suppose. So in that case, applying shortcut method of converting year to x will be tough, because what values you have to take for x so that sigma x will be 0. That will be tough. So therefore, I'm advising that in the exam, if question comes, don't go by the shortcut method, go by direct method. Okay, anybody is having any confusion on it? Sales forecasting?
No.
In direct method, if you
No, sir.
if you put, it will be 1, 3, 5, 6, 7. So that we can easily do. But in that short-term method means it's a bit time-consuming. Sometimes you may not arrive at the right option. So that way, it is better to go by the direct method. This is all about sales forecasting. If there is any question, please ask. Otherwise, I will go to the next concept. It seems everybody got it. So let us move on to the next concept. That is elasticity of demand. Before going to this, I am just confirming whether I have told this or not. Giffen goods and inferior goods distinction I have made the class.
Yes, sir.
Means in case of given goods, we compare demand with price, and demand law does not operate. In case of inferior goods, we compare income demand with income, which also does not follow the normal path. Generally, if income increases, demand increases, but in case of inferior commodities, income increases, demand of inferior commodity will reduce, because now as we are having more income, we can afford to better quality product, therefore demand for inferior quality product will come down. Then we come to the elastic demand. So far in the law of demand, we came to know that there is an inverse relationship between price and quantity demanded. It means if price is going up, demand is coming down, and the vice versa. But suppose you are a producer, a seller, you are planning to take a decision on pricing. Pricing means either price cut or price hike. Is that enough, this demand law, enough for you to take a decision for pricing? You know that if you are going to hike the price, demand will fall. With this knowledge, can you take a decision of price cut or price hike? No. I'm repeating once again. You have the knowledge about demand law. So far we have discussed. It means what? There is inverse relationship between price and quantity demanded. If price goes up, demand comes down. If price comes down, demand goes up. You are interested to augment, enhance the profitability. Therefore, you are planning to change the price. Change the price means maybe price cut or price hike. After knowing this demand law, will you take the decision, either price cut or price hike? No.
No.
Why?
It also
Okay.
depends on the market factor.
So it depends on the market.
Depends on market. Market means what? Market means what? Demand, aggregation of demand of your product. Aggregation of individual demand of the product.
So if the cost of everything is increasing, then we can increase the cost.
Increase the cost. No, you see. Suppose you know this one only, their price increased, demand will come down. Then probably if you don't know anything much more about this price demand relationship, you will think that why should I go for price hike and demand will come down? I will be keeping the price intact. But suppose you increase the price by 20%. Your demand came down by 1%, 2%. Then demand law is followed. Price increased, demand came down. But you are not going to lose the total revenue. While hiking the price by 20%, demand is falling just marginally by 1-2%. The total revenue will be increased. Why? Because per unit revenue or price will be much higher, and total volume of sales is not drastically fallen. It is marginally fallen only. So it will be adding to your profitability. It means,
Yes.
tell.
Yes, sir.
Yeah, it means what? Mere directional relationship, directional movement of price and quantity demanded cannot give you the point to take a decision whether to go for price cut strategy or price hike strategy. Rather, you need to know the percentage, a quantum change in price and quantity. If there is 1% hike in price, by what percent demand is falling, that you need to know. If 1% hike in price causing or going to cause 1% fall in demand, then from total revenue point of view, you are in no loss, no gain situation. If by hiking the 1% price, your demand is falling by 0.01% or 0.2%, then in spite of increase in price, your revenue, your profit will be more. Because price is hiking by 1%, demand is falling marginally by 0.1%, 0.2%, much less than 1%. Okay. Therefore, we need to know the extent of change in demand due to change in price, which was not covered in the law of demand. Therefore, the concept of elasticity of demand came into picture, which exhibits the quantum of change in demand due to a percentage change in the price, income, yeah, anything else, whatever variable factors are there. Okay. Now we'll define this concept first, elastic demand. I'm noting it down just to explain it in a better way. Degree of responsiveness of demand for a commodity due to change in the values of variables on which demand depends. So elastic demand can be defined as degree of responsiveness of demand for a commodity due to change in the values of the variables on which demand depends. This is the definition of the concept of elastic demand. So could you get this point? Degree means extent, the amount. To what extent? Responsiveness means what? Reactive. To what extent? Simply we can say to what extent demand reacts, demand responds. Demand means demand for a commodity response to change in the values of the variables on which demand depends. Variables on which demand depends means what? There are n number of variables we have already discussed. But out of those, three important variables we have highlighted. What are those? Those are price of the same commodity, income of the consumers, and prices of the commodity. So could you recollect?
Yes.
Yeah. So it means what? If at all price of the commodity changes, to what extent demand for that commodity responds? That is coming under this concept of elastic demand. So degree of responsiveness of demand for a commodity due to change in the values of the variables on which demand depends. And out of the n number of variables on which demand depends, we are just taking three important variables what we have already mentioned: price of the same commodity, income of the consumers, and prices of the different commodities. As we are taking three important variables, and elastic demand is going to reflect the relationship between demand and change in demand with respect to each of the variables. So we will be having three types of elasticity demand. Three types of elasticity demand. First is price elasticity demand. We can define in the same way, nothing much we will add here. Degree of responsiveness, we will start with that. Degree of responsiveness of demand for a commodity due to change in the price of the commodity, price of the said commodity. Okay, so degree of responsiveness of demand for a commodity due to change in the price of the said commodity. Means up till this, due to change in the, up till this is common for three types. Degree of responsiveness of demand for a commodity due to change in the price of the said commodity. This is price elasticity. Then comes, because we took P, then I will take. Second is income elasticity of demand. Same thing, degree of responsiveness of demand for a commodity due to change in the income of the consumers. So income elasticity demand is degree of responsiveness of demand for a commodity due to change in the income of the consumers. And third is cross. Why cross? Because we are comparing one commodity's demand with respect to another commodity's price. Cross elastic demand, that is degree of responsiveness of demand for a commodity due to change in the price of its related commodities or related commodities. Okay, so elastic demand can be defined as to what extent demand responds to change in the values of the variables on which demand depends. Because there are three important variables, PX, price of the commodity, income of the consumers, and prices of the related commodities, we'll be having three types of elastic demand: price elastic demand, income elastic demand, and cross elasticity of demand. So price elastic demand is degree of responsiveness of demand for a commodity due to change in the price of the said commodity, the same commodity. Commodity X, suppose, if there is change in commodity X price, what is going to what extent the demand is changing. Then income elastic demand, degree of responsiveness of demand for a commodity due to change in the income of the consumers. And cross is degree of responsiveness of demand for a commodity due to change in the price of its related commodity. Tea and coffee, fountain pen and ink and other things. So is it clear, these three types of elastic demand?
Yes.
So this is the definition of all these concepts like elastic demand, price elastic demand, income elastic demand, and price elastic demand. Now we will explain these three elastic demand in detail one by one. And out of these three, income is the biggest one. Sorry, price is the biggest one, first one. So now we'll discuss price elasticity demand in detail. It is denoted as EP, capital EP, or small e. Definition already we have given: degree of responsiveness of demand for a commodity due to change in the price of the commodity. It means if any commodity's price changes, then to what extent demand responds to that? To what extent demand changes? So this can be, price or demand can be measured through different methods. So first method is methods of measuring UP. UP is equal to percentage change in quantity demanded by percentage change in price. EP is equal to percentage change in quantity demanded by percentage change in price. You know how to compute percentage change of anything? That is the change by original into 100. Change by original into 100. Suppose P is the original price. P1 is the new price. New means changed price. Q means original quantity demanded. Q1 is new quantity demanded. Then change in P denoted as del P is equal to P1 minus P. Similarly, change in quantity demanded del Q is equal to Q1 minus Q. Okay. Now, as you are interested in this formula, so percentage change means what it will be? Del Q by Q into 100 divided by del P by P into 100. Percentage change in quantity demanded means change in quantity demanded by original quantity demanded into 100. Del Q by Q into 100 and del P by P into 100. To simplify it further, it will be 100 will be cancelled. Del Q by Q divided by del P by P is equal to del Q by Q to P by del P is equal to del Q by del P into P by Q. This is the formula. The formula for measuring price relative to demand as per the percentage method is del Q by del P into P by Q. Del Q means change in quantity demanded, del P change in price, P original price and Q original quantity demanded. Is it clear?
Yes.
Now we will try to find the algebraic sign of this EP, because we got to know EP is equal to del Q by del P to P by Q. So what will be the algebraic sign of this one? Price. There are four terms: P, Q, del P. We will test individually which term will be what sign of what sign. P. Can price be negative? Can no. Price cannot be negative. At best, price can be zero. Price zero means what? You are getting the product without paying anything. Means whatever commodities you are getting from nature. So these are coming under the free goods. But in our discussion, we don't concentrate on the free goods. Most goods can be two types. One is economic goods, second is free goods. Free goods are those goods for which we don't pay anything. Like whatever we are getting free air, free water, fruits from the forest, fish from the river, for which you are not paying anything, we are getting the product. And economic goods means what? Goods for which we have to pay, we are paying. So our concern is on economic goods. Okay. Now we can say P cannot be negative. Demand be negative?
Yes, sir.
Demand be negative. Can you give an example? Can demand be negative? No.
Sir, demand cannot be negative. Delta Q can be negative.
Yeah, we are asking about Q only. So demand Q cannot be negative. Maximum Q can be zero. Price is so high that we cannot afford to that. We cannot purchase. Q can be zero, but Q can be negative. So P and Q both, if tested, they cannot be negative. Between del P and del Q, both of them could be positive, could be negative. Negative or positive, that will say. Just tell del P and del Q. What type of algebraic sign they will carry? Already you know the law of demand. As per law of demand, there is inverse relationship between price and quantity demanded. Price increase means del P positive. Demand fall means del Q negative. Price fall means del P negative. Demand increase means del Q positive. Del P positive. Del Q positive. Means if one between these two is positive, other will be definitely negative. So we conclude that out of 4 terms, 1 term is negative. It may be del P or maybe del Q. So therefore, it will be always negative. Price less demand will be always negative, but while interpreting the result, we take the mod value. We take the mod value of means absolute value. Okay, is it clear?
So why it is so, sir? Why we take a mod value, sir, if it is coming to be the negative one?
No, because we are going to interpret. You see, while we will be discussing the different magnitude of a price less to demand, what I'll be discussing now, like perfectly elastic, perfectly inelastic, more elastic, less elastic, interelastic. There will be finding more elastic means EP greater than 1. Less elastic means less than 1. Interelastic means is equal to 1. But if always negative will be there, it will be always less than 1 only. Okay, I just am coming to that. So this is the theory behind this. Then we can have a small example to find the values. Let's say price and demand 10, 20, let's say 50 and 40. Price increase, demand came down. So we can have our EP. EP is equal to del Q by del P into P by Q. So this is your P. This is your P. This is your P1. This is your Q. This is your Q1. So now del P is equal to 20 minus 10 is equal to 10, and del Q is equal to 40 minus 50 is equal to minus 20. So now it will be del Q by del P minus 10 by 10 into P. P is equal to 10, Q is equal to 50. Sorry. It will be how much?
So minus 0.2.
Minus 0.2. You see, minus 0.2 means it is less than 1 will be minus 0.2, minus 5, whatever result comes, it will be less than 1. But we will take the EP mod. EP mod is equal to 0.2 just to interpret that what type of product it is. So we have a pause over here. From the methods of computing EP, we will now come to know different magnitude of the EP. To interpret this one, we'll have a pause over here. Then we'll go for the types of EP on the basis of magnitude. One is perfectly elastic demand. Perfectly elastic demand. It means what? If there is slight change in price, causes infinite change in quantity demanded. Means price of the product increased by, let's say, 1 paisa, yeah, 0.1 rupee, suppose. Demand drastically came down. Demand drastically came down. Okay. So this is called as a perfectly elastic demand. In this case, EP mod is equal to infinity, and demand curve becomes like this. Horizontal straight line. Demand curve becomes horizontal straight line. It means what? Price is not changing. Price not changing means price change in price is negligible, approaching to zero. Still, demand is infinitely changing. So perfectly elastic means demand curve will be horizontal straight line. It means with a very negligible change in price, which is approaching to zero, there is infinite change in quantity demanded. EP is equal to infinity. We don't have any such commodity practically which will be fitted here. Okay, it is theoretically valid concept. Second is perfectly inelastic demand. Just reverse of that one, another extreme. Here, EP mod is equal to zero, and demand curve becomes like this. Whatever may be the change in the price, quantity demanded will be unchanged. There will be no change in quantity demanded. Can you think of any such commodity? Irrespective of the change in the price, demand change won't be there. Some authors are giving the examples of salt and medicine, life-saving medicines, under this category. It also seems good, appropriate. Okay, salt we need uh, a specific quantum of salt for our household. We need specific amount of medicine for a particular disease. Something you want to tell? Okay.
Sir, but nothing can be perfectly inelastic.
I'm just coming to that. Just coming to that. Yeah. So they have given this example. But if you analyze intuitively, critically, there is no such commodity, what he rightly said, that which is perfectly inelastic. Even take the case of salt. In case of salt also, if the price changes, demand will definitely be changed. But here we have to talk about the to what extent price is changing. If you look at the practical point of view, practically the price of salt is around 20 kg, around 20 kg in India per kg. Sorry, 20 rupees per kg in India. And price, if price changes in 50 paisa, 1 rupee, 2 rupee like this. So because the price is less priced, and it is a very small fraction of our income, and price change is very small in a small change range, so it does not matter much. But if at all this price changes in hundreds or 500 rupees, like 20 rupees is now becoming 200 rupees per kg, then definitely the demand for salt will come down. We can put a question: Can we put less salt in our dishes? No, but will be economical in usage. Like now, because of less price product, we are carrying much, eating a small amount, wasting some amount. But if its price will be 500 rupees per kg, 200 rupees per kg, we will be taking that much only what we require, what we really need to consume. So we will be economical in usage by checking the wastage. That way, demand is coming down. Even in the case of medicine, you say that if we are suffering from a particular disease, we have to consume what the doctor has prescribed. But people are there who are unable to take the medicine and die. That means what? Price is not affordable by them. They are unable to demand. They could have demanded, but they could not demand. So therefore, no such commodity is there which is perfectly inelastic also. Okay, so we don't have time now. There are three more things: more elastic, less elastic, and interelastic. In the next class, we will discuss these three. Then we will come back to this interpretation part. Just note it. Then we will come to the second method of calculating the price elastic demand. Is it clear? First, we will explain these three: more, less, and unitary. Then we will interpret this one, what example we have done, or we can take another example there in the class and interpret. Then we will come to the second method of a computing PP. Please note it down in your answers. Sorry, note. Is it okay?
Yes.
One 119, 148, 165,
Present, sir.
168,
Present, sir.
205, 207, 213.
Yes, sir. Present, sir. 213.
Okay.
207 present.
227, 229, 294,
Present, sir.
318,
Present, sir.
320,